Hello everyone, welcome to my channel. In this video we will discuss about the underlying execution environment infrastructure behind the Lambda functions. So let's get started. So Lambda service invokes your function in an execution environment which provides a secure and isolated runtime environment to run your Lambda function. The execution environment manages the resources required to run your function. And the execution environment also provides lifecycle support for the function's runtime and any external extensions associated with the Lambda function. So we will see these things in detail in this video. When we create a Lambda function, under the hood, AWS configures an execution environment to run the Lambda function code. So whenever we create a Lambda function through the Lambda console or Lambda API, internally AWS configures an environment to run that Lambda function, which is known as the execution environment. Execution environments run on hardware virtualized virtual machines called micro VMs. A micro VM is dedicated to an AWS account. So for each AWS account, AWS creates a micro VM which is dedicated to that account. But that micro VM can be reused by different function execution environments within an account. The AWS owned hardware platform in which micro VMs are managed are called Lambda workers, which are EC2 machines. For each Lambda function, there is a separate execution environment. It is never shared across functions. Micro VMs are never shared across AWS accounts. So let us understand this with a diagram in next slide. So at the bottom level, we have the Lambda worker, which is EC2 instance. And in the EC2 instance, we have the host operating system. Then on above host operating system, there is a hypervisor. And we have this micro VM. And this micro VM is separate for each AWS account, and above the micro VM, execution environment is created which actually runs the Lambda function. So in the execution environment, what things we have? We have the Lambda runtime. This is the runtime that we choose when we create the Lambda function. For example, if we are creating Python function or Node.js function, we specify the runtime version when we create the function. And in the runtime, the actual function code runs. So this is an example of function 1 structure in the runtime. Similarly, for another function, we will have an execution environment above the micro VM, and then Lambda runtime for this function and the actual function code. So this is the Lambda function boundary. So for each Lambda function, we have a separate Lambda runtime and a separate execution environment. Similarly, for function 1, we have this function code, Lambda runtime and execution environment, which is a separate Lambda function boundary. So these two execution environments do not interfere with each other. Then this whole block is the AWS account boundary, which means this whole block is for a particular AWS account. So suppose we have more Lambda functions in our account. So above this, in this micro VM, more such execution environments will be created for each Lambda function. And this whole micro VM is separate for each AWS account. So suppose we have another AWS account. So for that AWS account, we will have a separate micro VM, and above the micro VM, we will have the same execution environment, Lambda runtime and function code. So this here is another AWS account. So let's see this in more detail in the next slide. So this is a diagram which I have taken from AWS documentation, which delves more into the detail of execution environment. So here we can see inside the micro VM we have this Lambda execution environment. This is for customer A account and this is for customer B account. So a single execution environment, this single execution environment may be reused by subsequent function invocations. This improves performance since it reduces the time taken to prepare the environment. There is also a local file system available at /tmp directory for all the Lambda functions. This is local to each function but shared across invocations within the same execution environment. If your function must access large libraries or files, these can be downloaded here first and then used by all subsequent invocations of your Lambda function. However, if you have a data intended only for single invocation, you should ensure that the data is only used in local scope variables. Or if using /tmp directory, delete any files from the /tmp directory before exiting. So here, as we can see by different colors, this green colored box is the execution environment, which is customer A's execution environment and the functions inside that environment, and this blue box is customer B's function, and all this other yellow is managed by AWS Lambda. So let us see a little bit deeper inside the execution environment in next slide. So execution environment, API, endpoints and processes. When we create the Lambda function, we specify the language runtime for the function, for example Node.js or Python, and other configuration information such as amount of memory available and the maximum execution time allowed for your function. So Lambda uses this information to set up the execution environment. Within the execution environment, the function's runtime and each external extension runs as a separate process. So here we can see inside the execution environment we have some boxes. So this is one box which is labeled as processes. So inside the execution environment, the function's runtime and each extension associated with the function runs as a separate process. The Lambda function and the runtime share the permissions, resources, credentials and environment variables. So the Lambda function and the runtime and the extensions share the roles which we have attached with the role or permission attached with the Lambda function. Any environment variables, those are shared by these processes. Then we have some APIs between the Lambda service and these processes. We have three APIs: runtime API, extension API and telemetry API. So the Lambda service communicates with the this runtime and extensions processes through these APIs. So first is runtime API. Runtime API is the our function's runtime communicates with Lambda using the runtime APIs. Extensions API communicate with Lambda using the extensions, whatever extensions we have in our Lambda function, those communicated with the extensions process using extensions API. And then we have telemetry API. Extensions can also receive log messages and other telemetry from the function using the telemetry API. So if the extension also sends some log messages or any other telemetry data to our Lambda function, those are communicated through the telemetry API. Now the extension environment also execution environment also provides lifecycle support for the function's runtime and any external extensions associated with the function. There are different phases in the lifecycle, which are init, invoke, and shutdown. Each phase starts with an event that Lambda sends to the runtime and to all the registered extensions. The runtime and each extension indicate completion by sending a next API request. So when the first phase in the lifecycle is completed, it sends the runtime, it indicates the completion by sending a next API request. So after init is completed, it sends next API request, which starts the invoke phase. Similarly, when invoke is completed, it sends the next API request, which starts the shutdown phase. So let us see this one by one. What happens in the init phase? So in the init phase starts all extensions. Extension which is called extension init. It bootstraps the runtime, which is called runtime init. It runs the function static code, which is function init, and runs any runtime hooks. The init phase, when the init phase ends, it ends with the runtime and all extensions signal that they are ready by sending a next API request. And the init phase is limited to 10 seconds. If all 3 tasks do not complete within 10 seconds, Lambda retries the init phase at the time of first function invocation with the configured function timeout. When after the init phase, we have the invoke phase, where the actual your Lambda code that we write or any extensions associated with it, the code for those is invoked. When a Lambda function is invoked in response to, it is invoked in response to the next API call from the init phase. So Lambda sends an invoke event to the runtime and to each extension. The function's timeout setting limits the duration of the entire invoke phase. For example, if you set the function timeout as 360 seconds, the function and all extensions need to complete within 360 seconds. The invoke phase ends after the runtime and all extensions signal that they are done by sending a next API request. So when the next API request is sent by the invoke phase, shutdown phase is started, which means our Lambda function code has completed. Now we need to shut down. When Lambda is about to shut down the runtime, it sends a shutdown event to each registered external extension. So external shutdown, extension shutdown is done. Extensions can use this time for final cleanup tasks. The shutdown event is a response to the next API request from invoke. The entire shutdown phase is limited to 2 seconds. If the runtime or any extension does not respond within these 2 seconds, Lambda terminates it via kill signal. So this is the end of execution environment lifecycle. So here invokes the function code, invoke phase, shutdown phase, shuts down the runtime, and final cleanup task. So this was all about Lambda execution environments in this video. If you like the video, please hit the like button, share the video, and hit the subscribe button if you have not already subscribed. Thank you for your time. See you in another video.